sort of like one thing. It's going to be a two-pronged approach, basically. So, what is climate change? According to the Met Office, climate change is a large-scale, long-term shift in the planet's weather patterns or average temperatures. This involves higher temperatures. In the past 100 years, it's risen by 0.89 degrees Celsius, which is extremely high compared to 0.89 degrees Celsius. That is a huge change. Compared to before the Industrial Revolution, so if I had a graph, it would be like going like that and then up like that, it's quite high. Changing rainfall, so increased rainfall over the mid-latitudes of the Northern Hemisphere, and dry summers, wet winters, which is kind of what we're experiencing now if you think that it's basically pinning it down for months on end, and then in theory you're probably going to have a dry summer. Change in nature, so different animal behaviours, changes in the seasons, for example, autumn's getting a bit later and spring's coming a bit earlier. And changes in nature could also be like, for example, butterflies are coming out earlier in the year and things like that. Sea level rises. Sea levels have risen 10 centimetres around the UK and 19 centimetres globally over the past 100 years, increasing over the last few decades. Retreating glaciers, so glaciers are melting, which is obviously contributing to the sea level rises. Sea ice reduction, it's been declining since the 1970s quite rapidly, roughly 4% per decade. However, the Antarctic is increasing 1.5% per decade, yeah. According to the information. I don't know, it's something to... I was going to research it further, but I just thought I'd throw it in there because it sounded quite cool.
No, it is cool.
Oh, well, I'll find out and tell you. And ice sheets. Areas of land covered by ice, Greenland's shrinking. That's one of the most important ones because sea ice, because of the water displacement, it doesn't change too much if it melts, whereas when it's actually on land, obviously all the water melts off and goes into the sea, which will cause it to rise. Right, so some of the bad boys in this. Oh yeah, sorry, if Greenland was to melt, then sea levels would rise by 7 metres. So, some people are going to be a bit underwater. Carbon dioxide, CO2. So that's obviously 2 oxygens, 1 carbon. Both the oxygens connected by double bonds to the carbon. It's the most abundant greenhouse gas. It's released mainly by industrial processes. It's the largest contributor to climate change caused by anthropogenic activity, so like human-based activity basically. It's approximately 390 parts per million volume currently. It's classed as a greenhouse gas due to the molecules being visible to visible light, whereas when it absorbs, it does absorb infrared and near-infrared, and when it absorbs it re-emits it, and because infrared is kind of like a bit like heat, it distributes it back into the earth, so it just basically causing a sort of blanket, putting it back down. It's emitted primarily through the burning of fossil fuels, so it's oil, natural gases, coal, solid waste, trees and wood products. Changes of the land also play a role, such as deforestation, soil degradation, add to the carbon dioxide to the atmosphere. While forestry growth takes it out of the atmosphere, so obviously if we're cutting back on the forests and things like that, then it's going to be changing the scale even more. Methane, CH4. So that's obviously 4 hydrogens connected to a carbon by single bonds. It's emitted during the production of and transport of coal, natural gas and oil. Methane emissions also result from livestock and agricultural practices and from the anaerobic decay of organic waste in places like landfills. Approximately, this is one of the reasons I'm focusing on dietary change, is because 60% of yearly emissions in the world are caused by anthropogenic sources, and 37% of that is caused by livestock industry. It's classed as a greenhouse gas due to molecules being visible to light, absorbing infrared and near-infrared and reflecting back down. And the other one that I'm looking at is nitrous oxide, so that's N2O. 298 times more potent as a greenhouse gas, so compared to carbon dioxide over a 100-year period, so it's quite a nasty bugger, really. It's the same as the other reasons, it's classed as greenhouse gas due to the building infrared light reflecting it. One thing I didn't look into, but it also happens to, is it causes ozone depletion. I didn't look at the actual chemical reaction, but I know that it due to it reacting with the ozone.
Does it cause it forms radicals?
Yeah, that's what I was thinking it was going to do, but
yeah.
Didn't look at it. Oh, and the other thing is livestock farming accounts for 65% of human-related nitrous oxide. So that's quite a hefty
livestock?
Yeah. From the ruminant cows and cow pat. Right, so how to reduce this? A change in diet. Moving from a meat-heavy diet will reduce methane and CO2 emissions. Livestock productions account for 78% of agricultural land in use today, which is, it could be either the actual pastures for the cows or the grain and stuff produced to feed cows. It takes 15 kilograms of grain and 30 kilograms of forage to produce 1 kilogram of beef, which is quite efficient really when you think of in terms of actual area of land per bit consumed. According to a study by Exeter University, a global reduction from 16.6% of daily caloric intake to 15% of meat. So say 15% of your diet is meat. Would sort the problem out of reducing carbon dioxide to safe levels. However, in the West, obviously it's a lot higher meat production and consumption, so it in some cases may even need to be halved. That would be 70 grams of beef and 325 grams of chicken and eggs per week, which would be the sort of safe level, which would cause a change. They stated that if the trend continues, by 2050 carbon dioxide produced by livestock will add an extra 55 parts per million to the atmosphere, which would put it over the 2-degree centigrade threshold, because they think that if it rises by 2 degrees, that's sort of a safe buffer they can go to. However, if the changes were implemented in a reduction and an improvement in the quality of the production, a 25 part per million reduction could be gained, which would avoid going over the 2-degree threshold. Also, it would save an estimated $20 trillion by the meat reduction, because otherwise that other $20 trillion would need to be invested into other carbon reduction, global warming reducing technologies. And then, obviously, there's a lot of land would be open to or use with a reduction in livestock. So, GM crops are currently growing on approximately 170 million hectares of land globally. That's not a lot, really, when a lot of the land is used by livestock. So this was changed over. Just in 2011 alone, with those 170 million hectares, an estimated 473 million kilograms of pesticides are saved due to them being more resistant to pests. 109 million hectares of new land being ploughed due to high yields, so there's less need to reuse the land. And due to this, if reduced greenhouse gas emissions, it would reduce greenhouse gas emissions by an equivalent of 23 billion tonnes of CO2 per year, which is obviously quite a lot. The impacts it would have. So, because of the amount of methane that's produced, nitrous oxide that's produced by livestock, the change would reduce it by millions of tonnes. An increased CO2 uptake by forests and crops, replacing areas previously required for livestock due to, as I said earlier, like deforestation happens due to livestock production, but they need a lot of land for it. These would then be able to grow back. Reduce nitrous oxide emissions, which again, as it's so potent, that would help. With the reduction of meat, just from that 16.5%, I think it was, to 15%, an estimated 10% reduction in greenhouse emissions would occur anthropogenically, so obviously volcanoes and stuff will still be contributing, but humans won't. And the land replaced with GM crops benefits towards reducing climate change, so increasing impact further and allowing an optimal combination to combat climate change. That's basically why I did the two-pronged approach, because if you're reducing livestock, yes, it's going to be working, but if the GM crops are as effective as they projected to be, then you might as well replace them with that. I know there's a lot of ethical and moral problems, but they're things that could be overcome. And yeah, that's basically it. That's references if anyone wants to look it up. Any questions? There's a bit talking, but I had a lot to go through.
They want us all to be vegetarians.
Pardon?
They want us all to be vegetarians.
Well, not necessarily vegetarian, just reduce the meat intake of that. It is. I know it's not going to happen for you, but you could replace it with things like hummus, beans, things like that. Yeah, that would give you the protein, and if in some ways it's actually more effective.
Not the same as the steak and chips.
It's not the same. But that's the other thing with GM crops as well, is that you could actually introduce like higher protein yields, like corn and things like that.
So the big advantage of GM crops is that they grow faster.
It's a mixture really. It's that because they're so adaptable. Like for example, as I said, protein would be an issue for people. You could increase protein yields, and actually because of the GM crops, the way they're designed is that they're more resistant to pests. There's less pesticides, which is less industry emissions. The higher yields caused by them because per hectare I can't remember the percentage, but it's a massive difference in the yield, which obviously has a knock-on effect with reducing the amount of replanting of seeds. The more yields you get, the more food you get, so the more you can supply, which the more reduce emissions.
That was really good, really impressive, wasn't it? Very excellent, well done.
You've got to talk for another
Yeah, it's very well presented as well.
another hour and 8 minutes if you could talk for.
Any other questions? I'll take this. No?
No, it was really, really